Hello friends, welcome to my YouTube channel Mech Maharashtra. We'll get more educational videos on this channel. Please go and watch. Now previous session we have seen the selection criterias for the bearings. Now we'll start with the numerical. Generally, as I told you, the numericals on this chapter, sliding contact bearing, is only one type of numerical, and that is on the basis on the Raimondis and Boyd method, which are given. So chart is given, everything is available, so which is a very simplest numericals. Just listen carefully, do the calculation carefully. That is the only funda to get the maximum marks in this chapter. Clear? I'll start with the numerical. I'll read one numerical over here. So what the numerical suggested, see, just first listen. The following data is given for 360 hydrodynamic bearing. Of course, we have seen the type of bearing. This is journal bearing or sleeve bearing, having radial load of 3.2 kilonewton. So I will have to write a given data. Radial load 3.2. Radial is nothing but toward the center, that is capital W. This will be the 3.2 kilonewton with the journal speed. Now journal is a shaft NS 1490 rpm. Then journal diameter, that is shaft diameter. It means small radius 25 and shaft diameter small d is 50 mm. With bearing length small n L 50 mm, radial clearance C 0.05 mm, and viscosity they have given 25 centipoise. I have told you in the theory session how to convert this centipoise into Newton second per mm square. So just please check the slide, please check the previous session. Now assuming that the total heat generated in the bearing is carried by the total oil flow in the bearing, this will need to assume, and calculate first coefficient of friction, means small value, that is F, power lost in friction, that is heat generation, PF, minimum oil film thickness, HO, correct, flow requirement in liter per minute, flow requirement is Q, liter per minute, so we need to calculate, and fifth one is a temperature rise, delta T. So this will be the clear from the reading the data, correct. This chart I'll explain later. Just read the example and try to solve the numericals with me if possible. It is very important. If you try to solve, then you will get it. Clear? Now see, the given data I have written. Radial load W is 3200 Newton, shaft speed 14,000 rpm. So we'll have to convert it into rps. Why? Because the lubrication flow is in the per second, it can be changed. So that's why we'll have to take rps. So divided by 60. Then diameter of the shaft 50, length 50 mm, clearance they have mentioned 0.05 mm, viscosity 25 centipoise. Now centipoise converted into Newton second per mm square. As I told you, the 1 centipoise is always equal to 10 raised to minus 9 Newton second per mm square. So directly I have written here, that is 25 into 10 raised to minus 9 Newton second per mm square. Now to find out small f, I told you PF, power lost, oil film thickness, Q, flow rate, and delta T, temperature. So one by one step will follow as per the given data, as per their requirement. We need to find out the detail. Very simple, all the things are given. Now first step, as we know, see, we have seen the chart. I'll show you the chart. This chart we have seen. Now first of all, in that chart, L by D is infinity, L by D is 1, L by D is 1 by 2, 1 by 4, and so on. Clear? So chart is given in the examination. No worry about that. It is directly given. Correct? Now out of this chart, L by D 4 values, which value I need to select, that I will have to decide first. Every time, every numerical we need to decide which chart L by D ratio I need to follow. So according to this, you can go here, you will get it. See, the length and diameter is 50-50. It means what? L by D ratio is 1. Correct? So I will refer for this numerical L by D ratio. This is L by D ratio, this 1 value. Correct? So I'm very clear that 1 value, this chart will be available, or this chart will be suitable for solving the numerical. Clear? First thing. Now go by this sequence. So first of all, we have seen the bearing characteristic, that is Sommerfeld number. Yes, that is bearing, this bearing characteristic number in nomenclature we have defined according to dimensionless parameter. First parameter is a Sommerfeld number, that is bearings characteristic. First calculate that, because we know the equation. You can see I had explained you this. First parameter, dimensional parameter, Sommerfeld number, bearing characteristic, R by C bracket square into mu ns by P. So go to by this sequence. So I have written here, just check it. See S is equal to R by C bracket square mu ns by P. Now calculate the parameter R, radius of the shaft, 50 diameter is given, 25 I have taken, clearance 0.05 given. Now mu, absolute viscosity, viscosity is given 25 centipoise, I have converted into 10 raised to minus 9, that is Newton second per mm square. So I have written here 25 here, clear. Then ns, shaft speed, which is in, we need to take in rps divided by 60, and bearing pressure. Now bearing pressure we need to calculate, that is P is equal to W by L into D. So W is nothing but the radial load 3200, L is 50, D is 50. So we'll get the bearing pressure, that is 1.28. So I have just put the value of the bearing pressure here, P 1.28. So through which we'll get the value of bearing characteristic number, which is the first part, 0.121. Clear friends? Clear this data? Now 1 to 1, and L by D ratio is 1, correct? So for that value I need to select this 0.1 to 1. So go to chart. Chart is given in the example. So this is 1 L by D ratio. So I need to use this. S value is, these are the S values they have given. Now S value, our value is 0.121, correct? So please check here. Getting it, dear friends? Here is the value of S, 0.121. So I need to write this row as it is by considering these values above titles. L by D 1, HO by C 0.4, eccentricity ratio 0.6, S is 0.121, R by C into F control flow variable 3.22, Q by RCNS flow variable 4.33, QS by Q 0.680, and P by P max by P 2.409. Clear? So this line, this row I have searched from the table and write as it is S. This will be the value. S is 0.121, L by D ratio 1, eccentricity ratio HO by C 5 value, R by C control flow variable, QS flow rate, and this. Clear? All this parameter they have given. Now it's our skill, first step is to find out the proper row from the chart. I have found this. Clear? Now we'll move toward what they are required. First, friction. So please check friction in which equation? F is here, correct? This is the friction equation. This we called as a coefficient of flow variable. I can use this equation, RCF, R by C into F is equal to how much from the chart? 3.22, as it is I have mentioned here, correct? R known 25, clearance given, F is not known because they are interested to know from the statement. So that's why F is equal to, this will be your coefficient of friction. Dimensionalist parameter, no unit, correct? First part is over. Understood, my dear friends? Every time for solving such kind of sliding contact bearing numericals, you need to find out L by D ratio and pick up the proper row from the chart and write down here. First of all, always need to calculate Sommerfeld number or bearing characteristic number. Clear? By this way you can get the value due to bearing characteristic number. If there is many more time, what happened, they will give oil film thickness also and clearance. So in that case I'll 0.4 I need to calculate and select accordingly from the chart. Clear? Now this will be the consideration. Friction is over. Now power lost, PF. Now PF is equal to, we have developed this equation as per the Raymundi's and Boyd method they have given. PF is equal to 2 pi ns FWR divided by 10 raised to 6. 2 pi as it is, ns it is in rps. Then friction we have calculated in first step, that is 0.00644. Then W is load, it is in Newton. Radius of the bearing 25, that is shaft, and 10 raised to 6. So will gives you the value of power loss directly 0.08 kilowatt. This is the power lost value. Second part is over as per their requirement. Third is oil film thickness, HO. Now see here HO by C term. So I need to calculate HO, means C need to calculate, but C is given. So just multiply the things. So HO by C is 0.4. So HO by C, therefore C is known, HO is 0.02 mm. Third part of the numerical is also over. Fourth one is a flow rate. Where is the flow rate? Here. Q by RC NS L by is equal to 4.33. I will have to write same term, 4.33. Here is the important part. Flow rate they have mentioned in the, that is, it should be calculated in liter per minute. Liter per minute. So that take care. See, now Q as it is, R 25, that is the radius of the shaft, C clearance, NS shaft speed in RPS, L is a 50, length 4.33. So the value of Q, that is flow rate, is gives in mm cube per second. Correct? Mm cube per second. And they are interested to know it is in a liter per minute. So while converting liter per minute, first of all, from second to minute I need to convert, it will be multiplied by the 60. Now mm cube, that's I will have to convert into mm cube, so 10 raised to minus 9 cube per minute. Clear? Next we are interested to liter per minute. Term is multiplied by 10 raised to 3. Correct? So by using this meter cube into liter, that is 10 raised to 3, will get the value of flow rate. It is in a liter per minute. Understood, dear friends? Again I will explain, just listen it. So Q by RC NSL as it is, I have taken from the chart. I'll put the values and got the value in mm cube per second. So while getting this value, I need to convert this second into minute because liter per minute required. So liter I cannot convert mm cube directly in liter, so I need to find out it is in mm cube, meter cube. That will be the 10 raised to minus 9, and then it will convert it into liter. So liter is nothing but 10 raised to 3 multiply, will get 0.4032, or instead of this value you can directly multiply, that is into 10 raised to minus 6 into 60, which will gives you liter per minute. Clear? Both the ways you can directly make the answer. 10 raised to minus 6 into 60 will get the liter per minute. Clear? By this way we can calculate the parameters. So here we'll check what this flow rate is also. Now temperature rise, we are having direct equation for the temperature rise. Delta T is equal to 2 pi ns FWR divided by rho Q Cp into 10 raised to 3. So rho is value is given 860 kg per meter cube, Cp specific heat 1.76. So put the value, all the values here. Correct? Now here is important, the value Q, mm cube per second, that value we need to consider. See this value for the calculating temperature range. So temperature range is 7.09 degrees centigrade. Clear? So please dear friends, revise the numerical from your side, solve the numericals from your side. I told you the stepwise procedure. Every time you need to pick up the one row from the chart given in the examination, and that skill is yours because you must know find out the L by D ratio first, and through that either bearing characteristic number or whichever with the given data you need to pick up, and then solve the numerical very easily. These are the straightforward numericals. Directly we are using these values. Clear?